If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everybody, welcome back to Anantha Lakshmi Academy. As told in the earlier videos, I am going to start today the very important topic, which is the solution of pair of linear equations in two variables, which is the topic 4.2 in your textbook. Solutions of pair of linear equations. Obviously, we are going to discuss in two variables, isn't it? Okay, so this is the topic that we are going to cover today. When I have covered this concept of the definition of the solution of a pair of linear equations in the part 1 as well. What did we discuss in there? When you have two equations in terms of two different variables which are x and y, the coordinates of x and y together which satisfy each of the two equations is known as the solution of pair of linear equations. That is nothing but when you have a value of x and y such that it satisfies both your equations. What were the equations in our earlier class? We took 3x plus 2y is equal to 80, which is Sita who bought 3 books and 2 pens at a cost of 80 rupees. And then we had Lakshmi who took 4 books and 3 pens at a cost of 110. These are the two equations we took, and by the model method we got x is equal to 20 and y is equal to 10, such that this pair has together satisfied both the conditions. During when we were discussing model method, this is what we figured out. Now we are going to discuss this solution of pair of linear equations. Having said that, what is the definition of the solution? Now let us discuss how do we figure out that. Now that earlier we have discussed model method, it was taking so long, no? Now let us come to let us discuss the other method, which is nothing but the graphical method, which is the graphical method. Graphical method. Even before discussing about graphical method, we are discussing about equations in two variables. When we need to have a unique solution, we said that we need to have at least two variables. Two equations, right? Let us consider a1x plus b1y plus c1 is equal to 0 is one equation. a2x plus b2y plus c2 is equal to 0. These are two linear equations. What are linear equations? Nothing but when you put them in the graph, you are going to get the graph as a line. Okay, so hence there are two lines. We have two lines. What are the possible outcomes? What are the possible outcomes when we put them on the graph? Let us figure out. One way is when you have two lines, when you put it on the graph, there is a chance that they might intersect. Okay, the first option is intersecting. Intersect, which is nothing but two lines intersect each other. Even before putting graphs, drawing the plots, we were trying to understand what may be the possible outcomes. Okay, when you put this, okay, x-axis and y-axis, what is the other thing? When we said intersect, the other they may be parallel. Okay, two lines parallel to each other, the other option. All right, the third option, what is the third option? The two lines are coincident, which is nothing but whatever the value of x and y we have lie on both the lines. Nothing but the two lines are coincident. Okay, now we understood that when we understood what is the solution of pair of linear equations in two variables. Now what is the method that we are going to use to get to that solution, which is nothing but graphical method. When you have two linear equations, what may be the possible outcomes? The two lines may intersect each other, or the two lines may be parallel to each other, or they end up coinciding each other. Okay, these are the three things which we have. Now let us try figuring that out for these two equations. Let us use this graphical method to get that. Okay, when we are trying to draw the graphs, what are the values which we need to have? We need to have x, y, isn't it? So let us figure that out. From the equation for 3x plus 2y is equal to 80, we have x. Then what does y become? 80 minus 3x by 2, isn't it? Now we need x and y coordinates for the same, isn't it? Now the second equation is 4x plus 3y is equal to 110. From here we can have x, and y is nothing but 110 minus 4x by 3. And finally we will be having x and y coordinates. Let me put this into a box so that we get to draw a graph. Alright, let me try this with 0. Okay, 0. Y is equal to, what does y become? 80 minus 0 by 2 is nothing but 80 by 2, which is 40. So this is going to be 0 comma 40, isn't it? That's the simplification which we are aware of. Now 10. Y is equal to 80 minus, just a minute, yeah, 80 minus 30 by 2, which is 50 by 2, 25. 10 comma 25. Now I am going to get 20. 20 is equal to, y is equal to 80 minus 3 2s are 60 by 2, which is 20 by 2. 20 by 2 is nothing but 10. So this is 20 comma 10. And the last value which I am going to consider is 30, which is y is equal to 80 minus 3 30s are 90 by 2. It is getting into the negative axis, 30 comma minus 5. Okay, let's do the same for the other equation as well. So this is going to be, okay, let me put this as x. Let us consider a value of 10 for x, which implies 110 minus 40 is nothing but 110 minus, okay, 110 minus 40. This is going to be 7, okay, 110 minus 40 is, yeah, 70 by 3. Next 20, for a value of 20, y is equal to 110 minus, okay, 110 minus 4 2s are 80 by 3, which is, okay, 80, 90, 130 by 3, which is 10. Next we are going to consider a value of 30, 110 minus 120 by 3, which is minus 10 by 3, which is somewhere around minus 3.3. When this comes to 70 by 3, this is nothing but 3 2s are 3 3s are 23.33 value somewhere. Okay, so this is going to be 10 comma 23.3, 20 comma 10, and this is 30 comma minus 3.3. Okay, all right. If you look at these tables, we have a common value which is nothing but 20 comma 10. That is just an observation. Keep it aside. Now let us try plotting the graph. Y-axis, and we have x-axis. So I told you, right, 0, 10, 20, 30 values I am going to place on the x-axis. So this is going to be 10, 20, 30. 10, 20, 30, minus 30, minus 20, minus 10, 10, 20, 30. So if you observe here, what is the maximum value that we have for y? On y is 40. So let me take the same scale of 10 on the y-axis as well. 10, 20, 30, 40. All right. Minus 10, minus 20, minus 30, and minus 40. Okay. Right. That now that we are going to plot the graph, you have the x and y coordinates. Let us plot that. 0 comma 40 for the first equation. 0 comma 40 we have. Then for 10 comma 25. For 10 we have a value of 25, which is exactly here. And then we have 20. For 20 we have 10, which is over here. And for a value of 30 we have minus 5, which is exactly here. Okay. Now let us join these dots. Okay, what is this equation? 3x plus 2y is equal to 80. This is the first graph. Now let us draw the same. 10 for 10 the value is 23.3, which is somewhere here, 23.3. And for 20 we have the same thing. And for 30 we have minus 3.3, which is somewhere over here. If you draw the graph, which is nothing but 4x plus 3y is equal to 110. Now what do you observe? These two lines are intersecting. What did we say? When we draw a graph of two lines, what may be the possible outcomes? One is to intersect, the other is to parallel, the third one is to coincide. Here if you observe these two graphs, they are intersecting at a point 20 comma 10. So this is nothing but when two graphs are intersecting, the point at which they are intersecting each other is nothing but the solution of the pair of two linear equations in two variables. So what is the solution? The solution of two equations is 20 comma 10. This is how we define the solution. Now that we have drawn a graph, what did we forget? We forgot the scale. Scale on x-axis, how did I take? On x-axis, 1 centimeter is equal to 10 units. On y-axis, sorry, this is 1 unit is equal to 10 centimeters. 1 unit is equal to 10 centimeters. On y-axis, 1 unit is equal to 10 centimeters. So, all right. Now, when you have a unique solution, like just we had 20 comma 10, a unique solution, those two lines are said to be when we have unique solution, two lines are said to be, what are they said to be? Consistent and independent to each other. So here what did we do? We understood what is a solution first. What happens when we draw a graph for two lines? What are the possible outcomes? When you get the possible outcome as intersecting, those two lines are said to be consistent and independent to each other. Now that we said when they are intersecting, the solutions are now that we said that the lines are intersecting, we have a unique solution, then those two lines are consistent and independent. Now the question comes up, there are two more possible outcomes. What would happen? What do we call those lines when the two lines are parallel to each other? They are inconsistent. They are nothing but inconsistent. Now when two lines are coincident, they are said to be consistent and dependent. So While using the graphical method to figure out the solution, we had three possible outcomes. When they are intersecting, that means we have a unique solution. Then the lines are said to be consistent and independent. Then when you have when the graph turns out to be that two lines are parallel to each other, then they are said to be inconsistent. Now when you have two lines that are coincident, then those are said to be consistent and dependent on each other. So that is about the concept of solutions of pair of linear equations in two variables. Let us jump into the next concept. Here we are at the next concept, which is relation between coefficients and nature of system of equations. When we have two equations of the form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, what did we learn in our polynomials concept? a1, a2, b1, b2, what are they called? a1 comma a2, b1 comma b2 are nothing but coefficients, isn't it? And what are the constants? c1 and c2 are constants. Is that what we have learned in polynomials chapter? Yes. Now we are going to establish a relation between the coefficients and nature of system of equations. System of equations, what is the nature? Nature of system of equations is nothing but which we have learned just before. What is it? Intersecting or parallel or coincident. That is what we have learned earlier. So we are going to establish so when two lines are intersecting, what would be their coefficients ratio? When two lines are parallel, what would be their coefficients ratio? That is what we are trying to figure out. Okay. This I can just write it and explain, but I want you to explain by writing it now and here itself, so that you will get a better understanding. Alright. So here in the first section, a1 by e2 is nothing but 3 by 4. b1 by b2 is 2 by 3. c1 by c2 is 80 by 110. Alright. Now, for the second one, a1 by a2 is 1 by 2. b1 by b2 is 2 by 4, which is nothing but 1 by 2. And the c1 by c2 ratio is 30 by 66, which is, okay, 10 by 22, which is nothing but, okay, let me do it like 6 5s are 6 11s are. Okay. Now for the last one, a1 by a2 is 3 by 1. This is 6 by 2 is nothing but 3, and 3900 by 1300 is also equal to 3. Alright. Now what are we going to do? Comparison of ratios. Here if you observe, a1 by a2 is not equal to b1 by b2. 3 by 4 is not equal to 2 by 3. That is what we wrote. Forget about c1 by c2. c1 by c2 is also not equal. But here in the next case, a1 by a2 is equal to b1 by b2. But this is not equal to c1 by c2. Here we did not consider c1 by c2 because the first two coefficients ratio itself is not equal. Here these two are equal, so we considered this. Okay, here that ratio is not equal. Now coming to the third one, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Now let me tell you a point over here. These are nothing but the two equations which we took as examples while figuring out the graphical method of figuring out the solution. So there we got the algebraic interpretation. Okay. What was the graphical representation that we got? The two lines are intersecting, isn't it? This is nothing but the nature of system of equations. How many solutions we get? One, or unique solution we got. So when the two lines are intersecting and have a unique solution, what is the algebraic interpretation? What did we figure out there? What did we say? The lines are consistent and independent. That is the algebraic interpretation. Here these two examples are nothing but wherein I said the lines may end up parallelly. This is nothing but the parallel case here. The parallel case. I did not explain these in terms of equations, but these are the equations which are considered in your textbook for drawing a parallel graph, and these are the equations which are considered for coincident graph to show that the two lines are coincident. I told you in the example, as the railway track goes on, there is no point of intersection, hence there is no solution for these things. Okay, for the parallel lines, as they are going parallelly like this, there is no point of intersection and hence there is no solution for these two lines. But for the coincident lines are nothing but the two lines are having the same solutions. So it will have infinitely many solutions. Infinitely many solutions. Okay, that is about the solutions. Now coming to the algebraic interpretation, what we have discussed, when the two lines are intersecting, they are consistent and independent. When they are parallel, they are inconsistent. And when they are coincident, these are consistent and dependent. Alright, this is the concept of relation between coefficients and nature of system of equations. Based on this, we have exercise problems wherein we will be asked to figure out these coefficients ratio and tell whether the graphical representation might be intersecting or parallel or coincident, or they might ask you to figure out it may have unique solution or no solution or infinitely many solutions. So this table is important. That is the reason I explained you in such a way that as if I am solving this. If I just draw this and try to explain, you will not get it. But instead of that, I tried solving this as if this is a problem so that you will get a better understanding. Alright, so that is about the concepts that are needed for us to solve exercise 4.1 problems. As usual, I'll be mentioning in all my videos before starting the exercises. Please go through the examples so that you will understand, you will get the concept of how to apply the conceptual part that you have learned into problems. How do we apply that you will know only while going through the examples. So go through the examples and get ready for the next video on exercise 4.1. Alright, and if you are if you think that the content is worth enough to understand, please pass it on to your 10th classmates or any of your relatives who are studying 10th class. Thank you for watching, and please do like, share and subscribe to Anantha Lakshmi Academy. Thank you.